My name is Simbak, and let me start the project result of Machine Learning Foundation for Product Managers. First, project topic. In this project, I'm going to build a model to predict the electrical energy output of combined cycle power plants. I recognize this problem is a regression task. So for this task, there are 5 columns in the dataset, which is temperature, ambient pressure, relative humidity, exhaust vacuum, and then finally the electrical energy output. So my approach is that there are 2 types of regression model. One is a very basic linear regression, and the second is random forest regressor. The reason why I chose the random forest regressor is that the model is an ensemble model that combines multiple decision trees, and it is often very robust to nonlinear relationships and outliers. The metric I used is mean squared error, mean absolute error, and R-squared error. Then I first checked the features correlation. As you can see, the AT temperature and V is strongly correlated with the output variables, and the direction is negatively correlated, and AP is moderately correlated with the output variable in a positive direction, and then RH is weakly correlated in a positive direction with the output variables. So the correlations, all features have correlations in some degree, so I decided to use all features. So for validations, for random forest regressor, I used the 100 decision trees using Python random forest regressor function from scikit-learn ensemble. Then I splitted the test data set as 20% of the data set. For this, I used the Python train test split function from scikit-learn model selection. And then I used the cross validation with the number of fold 5. I used the function cross-val score function from scikit-learn model selection. And then lastly, the performance of model is as below. So for all metric, random forest has a better performance. For MSE, random forest has lower MSE, which means that when being off by a lot, one time can be worse. Random forest is less off than linear regressor. Then MAE, random forest has 2.32, a lower MAE. This means that when being off by a little bit every time can be worse. Random forest is less off. And then lastly, R-squared. Random forest has higher R-squared values, which means that the variability in your dataset variable y is better explained by random forest. So overall, random forest has better performance than simple linear regressor. And then random forest, the result of random forest is from the 100 decision trees. Okay, that's all for my project. Thank you. See you.